Hello everyone, welcome to the video. In this video we'll be talking about architecture. So the probably long awaited moment where we're actually going to be drawing the architecture of the system. Now, if maybe you're not very experienced in software and you might be thinking, man, like it's been like 3, 4 episodes or 5 maybe, it's like the 5th episode and we haven't seen a line of code yet. Well, I know how that feels, and I feel it's very important to lay out a solid architecture first, know exactly what you're about to be doing, and then when you go ahead and execute, it's going to be that much simpler. Won't have to think as much as all the moving parts, and your decisions will be a lot easier to make. Implementation will be very straightforward. So that's why we're taking the time to very put ourselves into the system, put our minds to it, and just be able to draft a solid design so our job is a lot easier. So I'm not going to take too much more of your time. We're going to jump in on the computer. I just draw the system architecture, and then so make sure you stick around because after the architecture phase, we're going to be discussing, back on this camera, we're going to be discussing technology choices for a system, right? So make sure you stick around for that. And yeah, I'll see you on the other side.
All right. So, if you followed us this far, we drew the UI, we event stormed, domain modeled the domain, so I have a pretty good idea of what we want now. And now it's time to draw out the architecture. And we want to draw out the architecture to really bring the abstract to the concrete, exactly what we're going to do, exactly what are going to be the moving parts, which part's going to talk to what other parts. And we want to lay out our testing strategy so that we'll be able to do component tests, select how we're going to do our unit tests. So many people do unit tests like one test per function or something like that. That's like a very extreme. How I like to unit test is I don't like to select functions or classes that I'll unit test. I like to select small modules, which are still bigger than a few functions, but they're still smaller than a few systems. And what that allows is it prevents strong coupling between the tests and the implementations. And that's one of the big drawbacks of doing a lot of automated tests is they break every time you change the implementation, right? Or they can break at least. And so I feel a just a bit like a bit higher of an abstraction or a higher of a level of testing can be beneficial to get most of the gains of unit tests, but without the drawbacks of unit tests, which are they're extremely coupled. So that's one few things to keep in mind. So if we jump in here, I think the first part we're gonna actually start is this stock, because the stock price is going to be like the core part of and then let me like do alphabetical here. So we do stock. So the reason why I starting here is because first I know there's going to be this thing, and I know it's going to be like what's going to be the beginning of the catalyst of all the changes in the system, or most of the changes in the system. So I'm just going to start here. And but we could start basically anywhere, to be honest. Now that we drew everything out and stuff, so that kind of helps. And so I know there's going to be like a price changed, and I know it's going to have like an event here, and I like to represent events with like a lightning thingy because if you've used Visual Studio, like, well, now people are using the icon, like the lightning icon for events for a while now, but I think I first saw it in Visual Studio when, like in IntelliSense, when you select like your methods and stuff, the events would be represented with the lightning, and I think I kind of caught on pretty easily, so just doing it that way. And like here, this is like price updated, and boom. So what is this box? For now, is just like this module, this thing. I don't know exactly. It's going to be a group of functions. It's basically like a domain. It's a context for now. It's not very like something you can touch and feel and stuff. But it's still a good starting point. We don't have to like go insanely in depth because I think you're going to start to hit diminishing returns. Like you're going to take so much time thinking about the small details of the design that just like if you just stopped a bit earlier and start coding sooner, maybe like you can argue to some diminishing returns there. So it's a balance. Like you don't want to go like know exactly what variable you're going to create ahead of time. Like you don't have to go that far, but still, I think defining the events and how they connect to each other is a good value there. So there's our stock, and then where we represented, there's this indicator kind of sector or domain or whatever context. So indicator values. So an indicator, there's a like an indicator type and there's an indicator like instance because you can have RSI as an indicator, but you can configure it to have it like on a given stock with a different period value and a different period type. So they have to be like configurable. So there's kind of like that class object kind of relationship. Doesn't mean we're going to implement the classes and objects. We're probably going to do a like I don't know some record type or something like that. Or at least the descriptor is going to be like a something like that. But again, we don't have to go too much in depth. And we know that when the price updates, we know we're going to listen on this. So this is going to be actually going to draw the arrow in reverse because the stock is not going to know about the indicators. So that's one thing to it's pretty important to mention is there's a concept of dependency and the indicator depends on the stocks, right? And not the other way around. The stock price can't exist without the indicators itself. So that's something there. And you know what? For now, I'm not going to write out the exact events. Like I have that information here. I can always add it later if I want to. Might be just overkill for now. And one thing I want to talk about is events, like how we're going to implement these events. So we have like .NET events. So like in .NET, there is support for event and event handlers with delegates, kind of in like a C# or just in .NET in general. That's one thing we can do. There's a few drawbacks with these I find. The first drawback is by default they're synchronous and they get called one at a time. So it's like a single threaded operation, right? So there's uh, you you basically go through all the delegates in your event, and you go one by one. It'd be nice to have something that just like emits something, and then other people can just start with that on not necessarily bound synchronously, because at the end of the day, no shouldn't be like it should be totally independent, right? And the other thing is eventually we might need to scale this out. Like we might need like an event queue or something, or event stream or something like that. And that we would need that if we're going to be on different machines, and you can't just like subscribe an event handler that's on another machine, like on another process, right? So you would have to have inter-process communication, and it might or may not be on the same machine. And in that case, maybe we can benefit from a message queuing system or an event queuing system, but that's like very far down the line. So I think a happy medium would be maybe looking at observables or event streams that are in process but are not synchronous. So I'm gonna be doing a bit more research. I know there's a few things like there's like a reactive RX something, RX observables. There's like a few implementations out of .NET, and I'm gonna do like more research for which one I'm gonna select later. Like it's a detail, right? This is a detail that we don't really need to have in our architecture, but it's important to talk about, like know what we're gonna be using. So yeah, in the indicator, when that value updates, there's going to be here, and that's going to talk to. So this strategy is going to talk to some like signal thingy, which I haven't totally defined, but it's defined enough. Like there's going to be some buy signals, sell signals, stuff like that. So enough. And then the signal is going to notify some stuff, right? So, and these are all like events. They should not know about each other, or they should wait. Let's go over like who should know about who. So strategies definitely need to know about indicators. And indicators themselves don't really need to know about the strategies. So that's cool. And signals need to know about strategies, and strategies will know something. Like it has to know that it has to like a strategy will have a value, and there is going to be like actually the signal itself might be in the same field as the strategy, because the strategy is going to be like, oh, once my strategy hits a certain value, then it needs to emit something, like it needs to emit a signal. And so maybe it doesn't know that it's going to be a buy signal, but it's going to be like maybe a strategy. Okay, this is cool. So maybe a strategy can have like a condition, so a like win condition or a like emission condition or something like that, and then it knows like, okay, my condition has been met, so it can emit that event, and then the signal can look at that and then transform that. Okay, so I know that if a strategy hits a signal, and I know that the user assigned a certain strategy to a buy signal, then I can go ahead and emit a buy signal or sell signal, and then I can either notify if I need to or not, which can be handled by the notification domain, stuff like that. So that's the way I kind of see it right now, and a few of these will have commands. So a lot of these are like events right now. So we only draw like we only drew the events, but a few of these are going to have synchronous calls that are commands, right? So we have a few commands here. So we have to uh, there's going to be an entry point here, and that doesn't necessarily mean the API is going to be directly on this indicator, but we know that there are a few commands here. So there's um, and I'll actually go ahead and write this. I'll make it real simple. So here we're going to have uh, new indicator. We're going to have indicator edited, and we're going to have indicator removed, and all of these are from strategy. So new indicator added to all. I can actually type these out, I guess. I'm trying to optimize too much. New indicator added to strategy. Indicator edited for strategy, and indicator removed from strategy. Okay, and so these are basically going to be API calls, because they're going to be launched. They're going to be commanded from the interface, and yeah, so they're going to be coming in from the interface, and they're not going to be flowing from the event pipeline, if you will, or the event stream. Like we're not going to be uh, acting on those from the events. It's going to be like a different endpoint. So this is like where kind of like the CQRS, what they do really well is the segregation of commands and queries. So things that are done on the system and things that are queried on the system. Uh, and there's also like a command, like in the CQRS world, you can have like commands that are event driven. So like maybe another system is actually emitting an event and you want to listen on that event and do something. So there's like three endpoints. It's like the events, the commands, and then the queries. But we can still like take that idea and apply it to our environment where like we might be doing like a budget CQRS, if you will, where we're going to be is going to be querying because at the end of the day you need to have whether all the indicators are that are available to me, and these are not commands but endpoints, so we need to have getters here. We will need to have get indicators, so get indicators, and you can imagine there's going to be like probably just the get aspect. We're not going to be creating new indicators. We're going to be adding indicators to strategies, but we're not going to be creating indicators from the interface. So this is fine. And all of these, but the commonalities with all these is it's going to be communicated uh, via the client to the server. And like right now, as we mentioned in our previous video, we're going to see that we're going to want to update the UI if when a new stock price changes or when an indicator value changes or a strategy value changes. So that's something we need to draw that we have not drawn on this. So basically what I'm saying is there's going to be some endpoints here to get stuff. Boom. So it's going to be how can we do this? Let's put a big box and do we can just like call it indicator API, and it can be part of a so it might not be REST. Like this might not be REST HTTP because as we said we're going to do WebSockets, but our backend. So like we're going to have let's see some sort of API gateway, and the reason why we want that is just going to back up a little bit. Because these are like domain specific, but we have this application that is like the combination of all these domains, so it's going to sit on top. So each of these, like indicator, the strategies, the signals, and I want to do the stock prices as well. I'm going to remove this, to be honest. I'm just going to lasso this and just move it up somewhere. Like all of these at the end of the day are going to be routed, or I should say, let's draw the opposite actually. So I have the user interface. So this is the UI. This is the UI or the user interface, and the commands are going to come from there. They're going to go through WebSockets, so or Signal R. Like in this case, it's going to be Signal R because apparently it's a neat abstraction over it, and it has fallback mechanisms. It has a lot of stuff. It has good integration with .NET because it's it's been in the ecosystem a while. So Signal R, and so that's gonna have a Signal R, and then we're gonna have like that. Like this is our like where all the requests are handled. You can call it an API gateway to make it sound fancy, but at the end of the day, it's just going to be some like entity that knows about the downstream services and just calls the appropriate service. That's basically what we want. We just want something that the front end can call. The front end doesn't need to know about all these moving parts. It just needs to talk to this back end for front end kind of thing. No, route back the calls to the right functions. Like it doesn't have all these boxes, for the first iteration are really sitting on the same process, but they are logically separated still. Like they are not separated by process, but are still logically separated, so that firstly it's super testable. Second, it can't it can't scale if the project advances and you need more computing power or there's more requirements and like stuff needs to move. And so this looks super complicated, but in practice it's actually not complicated at all. I'm drawing extra boxes and stuff, but it might look scary. And I know I ranted over designing in my, I don't know if it's the last video that went before that, but this looks super complicated, but it actually is not. So please bear with me. So this is an API gateway, and the role of this is just having the right people take the commands that comes from the front end. And so this allows great segregation of responsibilities and abstraction for the user interface. So the user interface doesn't have to be super smart. At the end of the day, we want our user interface to be kind of dumb and to just display things. That's the ideal part because, well, maybe not in all cases. I might be overstepping there. Okay, so the API gateway, it's going to call, each of these. It's going to be very horrible, but it was what it is. So calling this strategy domain, and yeah. So, each of these might need some sort of database to store data. At the end of the day, we can have like the same database for now, but just make sure they like if you want to be really complicated, you can like desegregate all of these and have their own database. Which, wow, that's a horrible database, man. Whatever, it is what it is. And so the positive of each of having individual database is you'd be prepared for scaling. Is you'd have a good separation of concerns, and you basically will be ensuring that you're not accessing data that you're not like a good level of responsibility, like separating all the responsibilities and stuff. But in our case, it might be overkill. So we can put everything in the same database, but just make sure that we're not overstepping our boundaries. I think that's a perfectly reasonable for now. And I don't think I'm going to be like massively distributed nonsense. Well, not nonsense, obviously it's needed for many applications. I just think that it's kind of limiting. You're starting to write software and people are explaining very complicated topics, and you just have this feeling that you don't know enough. And at the end of the day, like, I just want to make programming fun. Well, obviously, I want to make good programs, but don't have to make things super. You can just start and increase. If you need more power, you need more whatever, you just change up afterwards, and you learn. Okay. So we have like basically everything here, and then the notifications. It might talk to something else, like some messenger bot or something. Let's postpone that decision. Doesn't really interfere with anything else. So we're actually not going to draw it. And so the interesting part is, where's the data coming from? Where's the stock data coming from? And we have this other account, right? So we have the account here. And obviously I'm just writing domain here. I'm just writing this big domain, but we have like these little sub-contexts, if that's a word, contexts, context high. And yeah, so we just want to make sure that we're not leaking, we're not leaking any concerns over that boundaries, because what that's going to do is it's going to make that change, or if I need to add another vendor, it's going to make it very much more complicated. And I know there's a decent probability of that happening. And you can think about it as like, imagine you're designing a vehicle. Like, you wouldn't want like if you want to change the wheels and you were like locked into the brand of the wheels, like so it's like changing a tire and it's like the same shape and everything, but it's like it wouldn't work if it was like Michelin tires or Pirellis or something like that. It'd just be like what, like doesn't even make sense. They couple the sources of the data or the frameworks of the data with the whole application, and just like, so that's what I would consider something that's poorly designed, because you really have to have separation of concerns and a certain aspect of, we should not have coupling on the implementations of our modules. Yeah, coupling. Well, basically coupling issues, but why you don't want your software to be coupled is it's not resilient to change or evolution. That's like the thing is, software evolves over time. This is going to be like a very long-term project because I'm going to be investing for basically the rest of my life. So I don't want to rewrite this in any shape or form. So yeah, there's many reasons why you don't want to have coupled code. That's like a big one. This is going to be connecting to the Questrade client. And so I looked a bit, and Questrade does offer an executable, or I should say a client, a C# client apparently. I haven't opened it up, but apparently it's a .NET based client. So can be able to integrate with F#. We're probably going to wrap a wrapper over it, just because it's going to be very, I just have a feeling it's going to be very bad. We'll see if we really need that or not. So the Questrade client is going to be, basically how it's implemented, it's probably going to access the Questrade API, which ideally we don't have to deal with if there's already a client library done. So that's pretty good, and that's how it talks. And it's going to open up a socket connection. So this is going to be a long living connection, because you have to stream the data. Like, you have to stream at a very fast pace, so sockets are going to be very good there. I don't know if it's like a WebSocket or not. I think it's going to be like I don't know. I haven't looked at it. It's either going to be a WebSocket or a TCP socket. If I would imagine. Ideally, we don't have to deal with that, but we will have to deal with the connection settings and stuff. And so there's going to be like a stateful connection here that we're going to have to handle. But that's fine. Should be fine. And basically, yeah, the account data is going to come from there as well. And there's no reason why there wouldn't be like another account here from another vendor, or another account here from another vendor. Like, so that's one thing to keep in mind. Okay, now we basically drew everything, I think. So now everything that changed here. We're probably going to have this middle layer here. So the API gateway is going to directly talk to each of these. But for the opposite, so events need to be pushed to the front end as well. So yeah, now it's trying to get really messy with the lines here. But basically, there's going to be some entity that's kind of in the API gateway or around it that's going to be listening to the events, but pushing them through the signal hub. I think that's how it works. And now I'm just going to remove this line, and then so it can be like here. Like, it doesn't have to be the API gateway, but it can be like very related things, and it can just be called whatever. No, it's going to be some kind of event listener, but we probably need a better name, because that doesn't really tell us what it does. It's going to be so maybe UI event listener, or that doesn't mean no. So maybe like a server event listener or something like that. Something that listens to servers events to basically, so it's going to be listening on all these events, or the relevant events it needs. And I think I mentioned in the last video that we're going to need some type of subscription mechanism, because there's going to be like too much data to just shovel everything to the UI. Because if we're like analyzing 500 stocks, price changes every every like second or so. So it's going to be like way too much data to push to the front end. And so what we can do is we can have a subscribe unsubscribe mechanism from the front end to make sure like we're only pushing events that we're listening on. And so the API gateway is going to talk to this. It's going to have like a subscription list or some like dictionary or something that will keep all the subscriptions of what the front end needs. So it's going to be very tailored to this delivery or mechanism, which is a UI interface. Makes sense to me. Maybe that's not this cluster hell of lines, but yeah, it makes sense to me. So there's also going to be like a strategy API, but it's going to be basically the same thing. I don't really want to draw it. Yeah, that works for me. So now that we drew this, we can start taking technological choices about what frameworks, what kind of, do we need a database where this application is going to be delivered? And so I'm going to send it to myself in the future, record it on the nice camera and the cool mic. So it's going to be much more fun to listen to. So I'll see you in 1 second. I thought about it a little bit more, and I think not all. So all these indicator APIs and all the API calls that are going to be called by the user interface that basically require more of a synchronous response. I don't think I'm going to be using SignalR for them, so I think I'm going to have SignalR for the kind of like server sent push updates and allow the user interface to use an API to get the indicators that they need or the what are the I don't know, the like stock tickers or something like that. Yeah, I think I'm going to leave it like that. Or I'm not going to leave it like that. I'm going to basically have a API gateway, but then on the side, so like SignalR, SignalR is going to be like this thing on the side, and then that thing will will handle bi-directional communication with the user interface if needed, but it's mostly going to be for events that are sent from the server. And so I think that allows the best for both worlds, and I'm looking forward to how that's actually going to be implemented in real life. So yeah.
All right, now we finally drafted the architecture. I'm really happy with it. So what we're going to be doing now is just defining what technology choices we're going to be using for that system. So in the first case, what we have to be looking at is, well, we can start by looking at infrastructure and like front end. So like you can start with either. So for front end, I've been discussing this on Twitter a little bit. I'm going to be using Sutil or Sutile. I'm not sure how it's pronounced, but basically it's a up and coming library started like just an experiment to replicate a little bit of what Svelte is trying to accomplish. So Svelte is a JavaScript framework that enables reactive programming without a virtual DOM. So like React uses a virtual DOM, so basically any change is made to the virtual DOM, the virtual document object model. It's going to try to diff all the parts of the virtual DOM and it'll only update the parts that have changed. Well, Svelte takes it another step further than that and will basically work on cache invalidation or just invalidation in general of your data. So basically, you have variables in place, and only when some variables in place change, then they'll update whatever other values are dependent on it. So it's much like Excel. It's much like incremental computations. So there's lots of information on this. You can check out a talk by Yaron Minsky, who works for Jane Street, about data-driven UIs or something like that. I'll link it down in the description. It's a very interesting talk, and a lot of these frameworks come from that idea. From that idea we want to eliminate waste of computations. We want to eliminate checking diffs that we don't need. This virtual DOM mechanism was like a leading It's a very leading way to do things. It's a very good step forward. But I believe we can take it even further than that. And I think F# is actually a great platform to do that because what happens is you don't even need a JavaScript framework underneath, right? We have a Fable compiler already. We can just write a library that acts much like Svelte, which is basically a compiler. Svelte is like has its own files and it compiles down to JavaScript, I believe. And we can basically do that with F# without going on top of something, right? Because like Fable React, we leverage React, or other frameworks we just like leverage the JavaScript counterparts. But actually what we can actually do, which is really smart, is we can write our own JavaScript compiler. Well, that's already done, but we can write our own JavaScript framework, if you will, like JavaScript framework, but we can write in F# and have strongly typed everything. So that's kind of a very interesting idea. So I'm heavily invested, well, not heavily invested yet, but I'm going to be trying Sutil for our project. We should probably include how to pronounce it correctly. Oh. All right, so that's for front end. So I'm going to be leveraging Fable and Sutil. And for the infrastructure, I'm going to be actually deploying this not in the cloud, but on a Raspberry Pi. So why am I doing this? Basically, I'm only going to be using this system myself. And the reason for that is, there's a lot of legality issues on having data like out in the public, and basically, it'd be very easy for me to like kind of cheat a little bit and basically if I output indicators or buy or sell signals on stocks, like if I buy the stock before anyone else, it'll like inflate the stock, and I can actually get into trouble telling people what to buy, like kind of manipulating the market or something like that. And just out of fear of that, I'm not going to do that for now. So it's going to be behind my just my home. Like I'm just going to have it in my home on the Raspberry Pi, run it. It's going to connect to the stock market data, and I'm going to receive notifications via Messenger or email or something like that. And even the thing, like even if I were to share this information with other people, and you can always add emails to a subscription list on my system and push like emails to them or something like that. So yeah, I don't believe I'm going to put it on the cloud anytime soon. And I thought about using Docker, so I think I'm going to be using Docker because I develop on a Windows machine, and just to simplify the deploy process, making things always work, very consistent. And I haven't really used Docker in the past, so it'd be a good learning opportunity for me. Well, I kind of have used it, but I'm not like as confident with it as I would like, so it'd be a good like learning opportunity for me. For my backend, I'm going to be using Giraffe. So basically here the choices are, well, there's a few choices, but either Giraffe, Saturn, or Falco. And I just kind of like Giraffe. I like the lack of opinionated stuff. I do lose out on some cool stuff in Saturn, but I just kind of like Giraffe, so I just pick it. And it's not because Saturn's worse or something like that or whatever. I just prefer Giraffe though. That's kind of my thing. And so now we've defined the architecture. We defined the front end. We've defined the infrastructure. Now Giraffe is going to be our back end. For databases, I'm just going to be using Postgres if I need a database. I probably will need a database. And what's interesting is, after I filmed the architecture part, I really thought about it, and I think like the stocks are going to be like CRUD operations, so I'm not going to be event sourcing those, but I might be event sourcing the indicators and the strategies, because indicators, their values, you're not going to receive the last state of an indicator. You need historical data to compute what's the current value of the indicator, so it might be beneficial to use event sourcing in that context, because prior values are important. Okay, so in the case like of an inventory, you do +1, -1, added 3, like whatever, like these operations, and event sources are very good for those systems because you don't receive, like an event does not send you the current state of the system. The current state of the system is an aggregation of all the prior events, right? As for the stock prices, when you receive a stock price, it sends you the current state of the system. So it doesn't make any sense to do event sourcing in that context, because you just store the last price and you send out the last price, and that's the state of the event. Like, you don't, obviously other systems can use the prior prices, but it just doesn't make sense. Like, the events would be new stock price 130, new stock price 128, new stock price whatever, and it'd just be very weird. You'd just be persisting the current state. So that doesn't make any sense for having an aggregate loop. And of course, I haven't explained what event sourcing and CQRS is, but we'll get to that eventually. So if you don't know what that means, I'll have a full video on it once I get there. So don't be worried about that. And yeah, so we might be looking at some event store implementations that already exist. I don't know if I want to waste too much time making my own, so I'll look at what currently exists and I'll make a decision later down the line. And for communication with the front end, basically we're going to have REST calls. So getting the current strategies, getting the indicators can be REST calls. So like we can have like a read model, we can basically do CQRS with the indicators and the strategy kind of domains. So these can be like CQRS type spaces, but for like the stocks, I'm not going to do any not going to do that kind of architecture for now. So I can just do some CRUD. So I'm going to do CRUD for the stock part of it, and I'm going to do event sourced, probably CQRS for the indicators and the strategies, and for notifications that doesn't really matter. It's going to be simple. It's going to be a straight function, basically notify, and basically to communicate with the front end. Like I said, there's going to be REST calls coming in, but there's also going to be WebSockets. So WebSockets are going to push the current price. They're going to push changes in indicator values and changes in strategy values to my front end. So I get like a very live web front end application that changes once the values change as well. So I'm actually really excited to implement that. It's going to be a cool system. And yeah, I think I went over all. Oh yeah, and for styling, I'm going to be using Bulma. But since Sutil is kind of new, there's not like a very cool way of doing Bulma. So we're going to integrate that, and maybe we'll end up making our little library to support Bulma with Sutil. We'll know what we'll see. It'll probably be called Solma. I don't know. So I think that's all for the technology choices. So to recap, we're going to be Sutil and Bulma on the front end. We're going to be using a Raspberry Pi and Docker to host our infrastructure. For database, relational database will be PostgreSQL, and we'll check for event store implementations. I see what other people are doing and make my own opinions about how I should do this. But basically, like, there should be like a contract of getting past events and appending new events. Once you get that contract in place, the underlying implementation should be able to vary. Well, you wouldn't want it to vary too much because you have like storing a lot of old events. Anyways, and yeah, we're going to be using REST API and SignalR for server send events, and like this kind of WebSocket abstraction to synchronize the front end with the back end events. So that's going to be the technology. Oh, and I forgot the stock data API. So stock data is going to be coming from Questrade, and my account data is going to be coming from Questrade API. So Questrade's a market maker or a broker or whatever. And I have a data package with them as to stream data. So that's going to be coming from them. And we're going to make it so I can change the data API or the account API, and maybe eventually, like in another world, or not another world, another time, I can maybe plug in a execution module where I can actually execute trades. So that can be very interesting as well. But for now, that's going to be out of scope because I don't think I can do it with Questrade, because Questrade does not allow executions apparently in their API. I have to look further, but. So that's basically it for the technology choices for our project. So in next video, what we're going to be doing is setting up the scaffolding, setting up the repository, It's kind of still boring stuff, but at least we're getting closer to that code. And then after that, we'll be finally able to start writing the damn code. So really happy about that. Hope you're excited. If you enjoyed the video, make sure to leave a like. Really helps the channel out. It's exploding right now, at least for my standards and expectations. Commenting also helps, so just write down any comment or question or whatever. And subscribe for more videos. So thanks for watching. I also do F# consulting and freelance development if you're interested. So you can check out my link down below to contact me on my website. And other than that, yeah, thanks for watching, and I'll see you in that next video. Peace!